Two AI systems are fighting over your computer right now. One of them works for you, one of them does not. The one that works for you is inside Microsoft's security infrastructure, a system called M-Dash that runs over 100 specialized AI agents simultaneously, scanning the deepest layers of Windows code for vulnerabilities that human researchers would take months to find, finding them in days, and patching them before the attackers can reach them. The one that does not work for you is inside the toolkits of nation-state hacking groups, ransomware operators, and cybercriminals, whose AI-powered analysis tools are scanning the exact same code, looking for the exact same vulnerabilities, racing to find them and weaponize them before the patch exists. This race is real. It is documented. It is happening right now on a timeline measured in hours between vulnerability, discovery, and active exploitation. And the margin between your machine being safe and your machine being compromised has been reduced to one thing: whether the update sitting in your Windows Update queue is installed on your system or not. Not next week, not when it is convenient, right now. Because the specific vulnerabilities we are going to discuss today, the ones that AI-powered attackers have already found, already exploited, and in some cases already used against real targets in documented nation-state attacks, are sitting on every unpatched Windows 11 machine as an open door that the people looking for open doors know exactly how to find. Let's go through what they found, how they found it, what it can do to your system, and what you need to do about it today. Let's start with the scale of what changed in 2026, because the numbers tell a story that makes everything else in this conversation make sense. The 2026 IBM X-Force Threat Intelligence Index reported a 44% increase in cyber attacks exploiting public-facing applications compared to the year before. Vulnerability exploitation drove 40% of all cyber incidents observed in 2025. The number of active ransomware operators increased by almost 50%. Attackers aren't reinventing playbooks, they're speeding them up with AI, said Mark Hughes, Global Managing Partner for Cybersecurity Services at IBM. The core issue is the same. Businesses are overwhelmed by software vulnerabilities. The difference now is speed. Speed. That is the word that defines what AI has changed about the threat landscape. The process of finding a vulnerability in software, understanding how to exploit it, developing a working attack tool, and deploying that tool against targets used to take weeks to months in the hands of even sophisticated threat actors. The reverse engineering required to understand a patched vulnerability from the patch itself, a technique called patch diffing, where researchers compare the pre-patch and post-patch binary to identify what changed and infer what the original flaw was a skilled manual process requiring deep technical expertise. AI has automated significant portions of this process. Akamai researchers used PatchDiff AI to dissect a patch and link it to real attacks within days of the patch being published. The same AI-powered analysis that security researchers use to understand patched vulnerabilities is available to attackers using equivalent tools, which means the window between a patch being published and an attacker developing a working exploit based on that patch has compressed dramatically. This compression is why the 2 0 days in the July 2026 Patch Tuesday update vulnerabilities that were already being actively exploited at the time the patch was released are a category of threat that requires immediate response rather than the leisurely update schedule many users apply to routine monthly patches. A 0-day being actively exploited is not a theoretical risk. It is a documented ongoing attack that affects every unpatched machine right now. And in the current environment where AI-powered tools can analyze a patch, reconstruct the original vulnerability, and develop a working exploit in hours, the window between patch released and exploit in the wild based on the patch has become short enough that delayed patching is genuinely dangerous in a way that it was not in earlier eras of the monthly patch cycle. Now let's talk about the specific vulnerabilities that define the current threat landscape. Because specific CVE numbers with specific descriptions are the information that allows you to understand what you're protecting against and why the urgency is real. CVE 2026-33824 has a CVSS score of 9. 8, the near maximum severity rating on the Common Vulnerability Scoring System, and is a double-free vulnerability in the IKEV2 service, reachable over UDP port 500, that yields code execution as local system. Let's unpack what that means in plain terms. IKEV2 is the Internet Key Exchange version 2 protocol used for establishing VPN connections and IPsec security associations. It runs as a Windows service called IKEXT. A double-free vulnerability occurs when memory that has already been freed is freed again. A memory management error that, in certain conditions, allows an attacker to control what happens to that memory region and use it to execute arbitrary code. Local system is the highest privilege level available on a Windows machine. It is the account under which the Windows operating system itself runs, with unrestricted access to every resource on the machine. And reachable over UDP port 500 means that an attacker on a network position where they can send UDP packets to your machine, which includes any attacker on the same network as you, any attacker who can reach your public IP address, and in many corporate configurations, any attacker who can reach the VPN endpoint, can trigger this vulnerability without needing any credentials, without needing you to click anything, without needing any interaction from you at all. A CVSS 9. 8.0 interaction network reachable vulnerability that gives an attacker full system control is as severe as Windows vulnerabilities get. CVE 2026-33827 is a remote unauthenticated use after free in TCP/IP. SES triggered by crafted IPv4 packets carrying the strict source and record route option. TCP/IP SIS is the Windows kernel driver that implements the TCP/IP networking stack, the foundational code that handles every network packet your machine sends and receives. A use after free in the kernel's TCP/IP driver, triggered by a specially crafted packet that can be sent from the network without authentication, is a path to kernel-level code execution. Code running at the deepest privilege level of the operating system, below the operating system itself. Both of these vulnerabilities, CVE 2026-33824 and CVE 2026-33807, were discovered by Microsoft's M-AI system and patched in the May 2026 Patch Tuesday. If you have not installed your May or subsequent updates, these specific vulnerabilities are present and exploitable on your machine right now. CVE 2026-322-202 is a Windows Shell spoofing vulnerability that was actively exploited and added to CISA's known exploited vulnerabilities catalog. Federal agencies were given until May 12th to patch the bug. CVE 2026-32202 is the result of an incomplete patch for a prior Windows Shell vulnerability, CVE 2026-21510, which the Russia-linked hacking group APT28 used in a cyber attack campaign against Ukraine and other European countries. APT28, also known as Fancy Bear, is one of the most sophisticated and well-resourced nation-state threat actors in the world, operating under the direction of Russia's Military Intelligence Directorate, the GRU. Their deployment of an exploit chain against Windows Shell vulnerabilities in a campaign targeting Ukraine and European countries is the clearest possible illustration of how AI-accelerated vulnerability discovery translates into real-world geopolitical attacks against real targets. The vulnerabilities that AI found in weapons were not hypothetical. They were used in documented nation-state cyber attacks. CVE 2026-21513 in the MS-HTML framework hit all Windows versions, earned a CVSS score of 8.8, and saw active exploitation in the wild by APT28. The vulnerability hides in IE-frame DLL, part of Internet Explorer's legacy code. It has flaws in hyperlink navigation logic, letting attackers slip past browser safeguards. Weak URL checks feed malicious input to shell execute XW, which runs local or remote files outside the sandbox. Attackers bypass mark of the web and IE enhanced security configuration using nested iframes and DOM tricks. A malicious LNK file flagged on VirusTotal January 30th, 2026 kicks it off. The presence of exploitable code in Internet Explorer's legacy framework code that has been nominally retired, but whose components remain present in Windows for backward compatibility, illustrates a recurring challenge in operating system security. Old code that is partially retained for compatibility purposes carries old vulnerabilities that may not have received the same scrutiny as actively developed components, and that sophisticated threat actors specifically target because the legacy code's attack surface is less well monitored. CVE 2026-544121, tracked as Certighost, is a Windows Active Directory Certificate Services vulnerability that was fixed in the July 2026 Patch Tuesday, and for which a proof-of-concept exploit has now been publicly released. An authenticated attacker could manipulate attributes associated with a machine account and obtain a certificate from Active Directory Certificate Services that allows authentication as that machine via PKINIT. If the attacker can target a domain controller account, they could authenticate as the domain controller and perform privileged Active Directory operations. The public release of a working proof-of-concept exploit for Certighost means that the knowledge required to exploit this vulnerability is now freely available, not restricted to sophisticated nation-state actors with substantial resources, but accessible to any threat actor who can read a GitHub repository. The window between the POC publication and widespread exploitation in commodity ransomware campaigns and opportunistic attacks is historically short, often days. CVE 2026-58527 is a race condition in Windows runtime that could allow an attacker with a low privilege foothold on a system to escalate to full system rights. The flaw affects all currently supported versions of Windows 11 and Windows Server, and there is no mitigation short of applying the update. Unlike some vulnerabilities where you can disable a service or apply a registry key, there's no alternative to installing the cumulative update. Privilege escalation vulnerabilities like CVE 2026-58-7 are a critical component of multi-stage attacks. An attacker who gains initial access to a system through a phishing email, a malicious download, or any other initial compromise vector may have limited privileges that prevent them from doing their most damaging work, exfiltrating sensitive data, deploying ransomware, creating persistent backdoors. A privilege escalation vulnerability that reliably elevates any low privilege foothold to full system control is the tool that transforms a limited initial compromise into a complete system takeover. Now let's talk about the AI systems on both sides of this race in more detail, because understanding what M- actually does explains both why the recent patches are so important and why the pace and size of patching is going to continue at the scale we discussed in the previous episode. M- multi-model agentic scanning harness orchestrates more than 100 specialized AI agents across an ensemble of frontier and distilled models to find, debate, and prove exploitable bugs from end to end. The system spans the Windows TCP IP stack, the IKXT IPsec service, HTTP, SYS, NetLogun, DNS resolution, and the Telnet client. The architecture of M- is specifically designed to address the failure modes of earlier automated vulnerability discovery systems. Rather than relying on a single AI model, M- runs a staged workflow. A scanner pipeline first identifies candidate vulnerabilities across critical binaries, multiple agent families, then debate whether each finding is genuinely exploitable, and a final prover pipeline constructs proof-of-concept triggers to confirm real bugs, filtering out false positives before any finding reaches the engineering team. This multi-stage architecture discover, debate, prove is designed to solve the false positive problem that has historically made automated vulnerability scanning impractical at scale. Earlier static analysis tools generated enormous numbers of potential vulnerability flags, most of which were not actually exploitable, requiring human engineers to review thousands of false positives to find a handful of genuine vulnerabilities. M-'s prover pipeline, the stage that constructs an actual working proof-of-concept trigger for each finding before it reaches a human, ensures that only confirmed, provably exploitable vulnerabilities are escalated, eliminating the false positive burden that made previous automation impractical. Validation tests showed M- achieved 96% recall on CLFs, SIS, and 100% recall on TCP/IP. SIS, when run against historical MSRC vulnerability cases, demonstrating detection-grade reliability. The adversarial AI tools that nation-state and criminal threat actors are using operate on similar principles, but are deployed in the opposite direction, not to patch vulnerabilities, but to find them and exploit them before patches exist. Hackers can use AI to find and take advantage of vulnerabilities that could then be weaponized. It's not just discovery that's been sped up. Reverse engineering security flaws is now a quicker process because of AI. That means attackers can find flaws and quickly take advantage of them before traditional methods of protection could take effect. The specific technique of using AI to analyze patches and reconstruct the original vulnerability, illustrated by Akamai's PatchDiff AI tool applied to the APT28 MSHTML attack campaign, means that even vulnerabilities that have been patched can become the basis for rapidly developed exploits, targeting machines that have not yet installed the patch. The race is not just between attackers finding 0 days and Microsoft patching them. It is also between Microsoft releasing a patch and attackers reverse engineering the patch to understand and weaponize the underlying vulnerability before most users have installed the fix. Let's now address something important about who is most at risk and why, because the threat landscape described by these CVEs is not equally distributed across all users. The network reachable vulnerabilities, CVE 2026-33824 and CVE 2026-33827, which can be triggered by sending specially crafted packets over a network without any user interaction, have their most severe implications for machines directly exposed to the internet or accessible from untrusted networks. Enterprise servers, publicly accessible systems, machines on shared networks in hotels, coffee shops, airports or co-working spaces, and home routers with port forwarding rules that expose Windows services directly to the internet are in the highest risk category for these specific vulnerabilities. Home users whose Windows machines sit behind a NAT router with no deliberate port forwarding face a lower but not zero risk from network reachable vulnerabilities, because NAT provides incidental rather than intentional isolation and can be bypassed through various techniques. The Windows Shell and MSHTML vulnerabilities, CVE 2026-32202 and CVE 2026-21513, have a different risk profile. These require the delivery of a malicious file that the user opens or interacts with. The APT28 campaign used malicious LNK shortcut files delivered through targeted spear phishing attacks. The user risk here is primarily about phishing and social engineering. The vulnerability provides the technical mechanism for the attack, but the attacker still needs to get a malicious file in front of you and convince you to interact with it. Good email hygiene, skepticism about unexpected attachments and links, and the kind of general security awareness that treats unexpected files from unfamiliar sources with appropriate caution are meaningful risk reduction measures here, complementing but not replacing the importance of patching. The Active Directory Certificate Services vulnerability, Certighost CVE 2026 FOSS4 or 1921, primarily affects enterprise environments and is of lower direct relevance to individual home users who are not operating within a Windows domain with certificate services configured. However, for any user who connects to a corporate network through a VPN or remote desktop, the security of the corporate environment's Active Directory infrastructure is directly relevant to their security. And IT administrators at organizations using Windows domain infrastructure should treat this vulnerability as urgent given the public availability of a working proof of concept. The Privilege Escalation Vulnerability, CVE 2026-58527, is universally relevant. It affects every Windows 11 machine, requires only low privilege initial access to exploit, and has no workaround other than the patch. In the context of a multi-stage attack where initial access is gained through a phishing email or a vulnerable public-facing application, CVE 2026 and 58527 is the tool that converts limited initial access into full system compromise. Patching it closes the escalation pathway that makes initial access as damaging as it would otherwise be. Now, let's get into the practical steps. What you need to do right now on your specific machine to address these vulnerabilities and build the ongoing security posture that the current AI-accelerated threat environment demands. The first and most urgent step is installing the July 2026 cumulative update, KB51016500 immediately, if you have not already done so. This update includes patches for all of the July disclosed vulnerabilities we discussed, including CVE 2026-58527, the Windows Runtime Privilege Escalation, as well as the fixes for the 570 total vulnerabilities addressed in July's Patch Tuesday. Open Settings, then Windows Update, and check for updates. If KB511 appears, install it and restart. If you are a Dell user who was blocked from receiving this update due to the thermal runaway compatibility issue discussed in a previous episode, install the emergency out-of-band update KB51221767, which resolves both the thermal issue and provides the security coverage of the July update. If your Dell is in the affected category and you have installed neither update, your machine is currently exposed to the security vulnerabilities in the July package. Prioritize getting the correct update installed. The second step is verifying that your May and June 2026 cumulative updates are also installed. Because the M-discovered vulnerabilities CVE 2026-33824 and CVE 2026-33827, the CVSS 9, 8, ICAV2 double free, and the TCP/IP. Sys use after free were patched in the May 2026 Patch Tuesday. If you have been delaying updates for multiple months, your machine may be exposed to these network reachable critical vulnerabilities as well. Open Windows Update, then Update History, and verify that the May and June cumulative updates appear as successfully installed. If they do not, check for updates and install all pending cumulative updates before focusing on the July package. The third step is checking whether the April 2026 Windows Shell patch that addressed CVE 2026-32202 is installed. The Hacker News and CISA both documented this vulnerability as actively exploited, with federal agencies given a hard May 12th deadline. Verifying the April cumulative update appears in your update, history confirms this specific vulnerability is patched on your machine. The fourth step involves reviewing your Windows Defender and Microsoft Defender settings to ensure real-time protection is active and definitions are current. Navigate to Windows Security, then Virus and Threat Protection, and verify that real-time protection is on and that the protection definition update date is within the last 24 hours. Microsoft Defender's threat definition database is updated multiple times daily and provides detection capability for known malware and exploit tools that use the documented vulnerabilities as their initial attack vector. Current definitions are the last line of defense for attacks that manage to reach your machine before a patch is installed. The fifth step is reviewing and tightening your Windows firewall configuration, specifically for the network reachable vulnerability categories. The most protective configuration for home users is ensuring that Windows Firewall is set to block all inbound connections on public networks by default, with only explicitly authorized exceptions. Navigate to Windows Security, then Firewall and Network Protection, and verify that the firewall is active for all network profiles, domain, private, and public. For the public network profile specifically, ensure the setting to block all inbound connections, including those in the list of allowed apps, is either enabled or that the list of allowed inbound exceptions is minimal and deliberate. The sixth step is evaluating whether you need the IKXT service active on your machine, because CVE 2026-33824 specifically targets this service. IKXT manages IKE and authIP IPsec keying modules, functionality required for VPN connections using IPsec. If you do not use Windows built-in VPN client or any IPsec-dependent connectivity, you can disable the IKXT service as a defense in depth measure while ensuring the July cumulative update is installed. Disabling an unneeded service eliminates its attack surface entirely. To check and modify the service state, open services through the Start menu search, find IKE and authIP IPsec keying modules, and set its startup type to manual or disabled if you are confident it is not required for your connectivity needs. Note that some corporate VPN solutions depend on this service. Verify before disabling. The seventh step specifically addresses the legacy MS-HTML and Windows Shell vulnerability surface that APT28 exploited. The primary risk vector for these vulnerabilities is malicious LNK shortcut files and similar weaponized file types delivered through phishing. Reviewing your email client's handling of attachments, ensuring that file extensions are visible in Windows Explorer, which requires unchecking hide extensions for known file types in folder options, allows you to see on LNK and other potentially dangerous extensions, rather than the misleadingly innocent-looking display names that hidden extensions produce. A file named document that appears to be a Word document, but is actually document. LNK is only identifiable as a shortcut when extensions are visible. The eighth step is building an update discipline that matches the current threat environment's tempo. The previous model of install updates when convenient, maybe wait a week to see if they break anything, was defensible when the time between patch release and AI-accelerated exploit development was measured in weeks. In the current environment, where PatchDiff AI and equivalent tools can reconstruct exploits from patches within days, the delay between patch availability and installation should be measured in hours for critical and actively exploited vulnerabilities, not days or weeks. Configuring Windows Update to install updates automatically, including through active hours restarts for critical security updates. Let's close by addressing the question that the AI versus AI framing naturally raises. If M- is finding vulnerabilities before attackers do, does that mean Windows is becoming more secure? The honest answer is yes and no, and the distinction matters. M- finding vulnerabilities before attackers reach them is unambiguously a security improvement. It converts potential 0 days into patched vulnerabilities, closing attack paths before they are weaponized. The 16 vulnerabilities M- found and patched in May, including the 2 critical network reachable remote code execution flaws, represent attacks that never happened because the defender found the flaw first. But the attacker-side AI capability is also real and growing. GenAI lowers the barrier for low-skilled actors, speeding attacks on supply chains and SaaS integrations. Vulnerability exploitation drove 40% of cyber incidents. The number of ransomware operators increased almost 50%. The democratization of AI-powered attack tools means that capabilities previously restricted to sophisticated nation-state actors are becoming accessible to a broader range of threat actors. Ransomware groups, criminal organizations, and opportunistic attackers who previously lacked the technical depth to reverse engineer patches and develop working exploits. The race between M- and the attacker AI tools is not a race between 2 evenly matched adversaries operating at a constant capability level. Both sides are becoming more capable simultaneously, and the consequence for users is a threat environment where the urgency of staying patched is higher than it has ever been. The patch exists. The update is waiting in your Windows Update queue. The specific vulnerabilities that AI-powered attackers have found, weaponized, and in some cases already deployed against real targets in documented nation-state attacks are either patched on your machine or they are not. There is no partial credit. There is no close enough. The update either installs or it does not, and the door is either closed or it is open. Right now, before you do anything else today, check Windows Update. Install what is waiting. Restart if required. And do it with the understanding that on the other side of the decision to delay is an AI system that finds open doors faster than any human attacker ever could, and that does not wait for a convenient time.